Today we're going to look at how to use our unit circle to develop some trigonometric identities. So we're going to start like we have before on the unit circle, and we know that a point where a line intersects out of the circle can be called XY. And we also know that this can create a right triangle with the central or an angle in standard position called theta and XY. And our radius on our unit circle is 1. So we have looked at how we can use the Pythagorean theorem to represent the relationship between the three sides of this right triangle. So we can say that's x squared plus y squared equals 1 squared, which equals x squared plus y squared equals 1. But then if you remember, we also defined x and y as cosine theta, comma, sine of theta. And we remember that is true because sine is opposite y over hypotenuse. Let me write that down over here. So we have sine of theta is opposite over hypotenuse, which is just y. And cosine of theta is adjacent over hypotenuse, which is just x. So we can replace our x and y with cosine theta and sine theta. And so we can do the same thing in our Pythagorean theorem here. We can go ahead and say that x squared is the same thing as cosine of theta squared, and y squared is the same thing as sine of theta squared, and that still equals 1. And then to simplify this expression, we would say something like cosine theta squared. In trigonometry, we also write that as cosine squared theta. Those are considered to be the same thing. They are equal. So we can simplify this expression down to cosine squared theta plus sine squared theta equals 1. And so this is what we would call an identity. We would call this an identity because we are rewriting this expression using trig functions. And we have this left-hand side equals the right-hand side. And this is true every single time. So this is our Pythagorean identity. And we're going to use this today to evaluate sine and cosine when we're given only a little bit of information. So one other definition we're going to use today is we're going to look at tangent. And if you remember, we defined tangent. Let's see, tangent over here. Tangent of theta would be the same thing as opposite over adjacent, y over x. But since we've gone ahead and rewritten y and x as cosine and sine, we can also rewrite tangent as y, which is sine, over x, which is cosine. So this is another identity that we are going to be using today. So again, we're just rewriting tangent in terms of sine and cosine. So let's go ahead and look at our first example. It says confirm the Pythagorean identity for when theta equals pi over 3. So all we're doing right now is we're just showing that this statement is true for a given angle. So what we're going to do is just substitute in pi over 3. So we'd say cosine squared pi over 3 plus sine squared pi over 3. And we're going to show that equals 1. So we know cosine squared pi over 3 is the same thing as cosine of pi over 3 squared. And similarly for sine of pi over 3 squared. And we're showing that this equals 1. So all we have to do here is evaluate sine and cosine of pi over 3. So if you remember, pi over 3 gives us a reference angle of 60 degrees. So on that 60-degree, 30, 60, 90 triangle, we know this side would be 1. The side adjacent to the 30-degree angle would be √3, and this would be 2. So cosine would be 1/2 because it's adjacent over hypotenuse, and sine would be opposite over adjacent. So root 3 over 2. So again, we're just showing that this expression is equal to 1. So let's see, we have 1/2 squared, which is 1/2 times 1/2, which is 1/4. And then we have root 3 over 2 times root 3 over 2. So root 3 squared would just be 3. And 2 squared, the denominator would just be 4. So we know 1/4 plus 3/4 is the same thing as 1. So we have shown this identity to be true for this given angle of pi over 3. All right, another way that we can use these identities is we can use them to solve for other trigonometric ratios or functions. So in this next example, we're given sine is equal to a value, and we're also given some information about where theta lies. So if you remember from our work from last week, we talked about on our coordinate plane in the different quadrants, we know different functions are positive and negative. So remember, we say cosine comma sine is x comma y. So in quadrant 1, they are both positive. In quadrant 2, cosine is negative, sine is positive. In quadrant 3, both sine and cosine are negative. And in quadrant 4, cosine and is positive and sine is negative. We also remember that tangent is just the quotient of these signs. So in quadrants 1 and 3, tangent is positive, and in quadrants 2 and 4, tangent is negative. So when they're telling us here, when they're telling us that our theta is between pi halves and pi, what they're telling us is what quadrant we are in. So pi halves, remember, is 90 degrees and pi is 180. So we know in this case, our theta is living in quadrant 2. So why is that important to know? Because that right away, before we even start solving the problem, that tells us that cosine is going to be negative, right? Because cosine is our x, it corresponds to our x values. So on the quadrant 2, in quadrant 2, the x-axis is negative. So cosine will also be negative. And then we know tangent is going to be the quotient of these two. So remember, it's sine over cosine. So positive over a negative is also going to be a negative. So when we're finding cosine and we're finding tangent, then that we know that we have to say, hey, because it's in quadrant 2, these are both negative. So now let's go ahead and solve. So we are given this value that sine is 0.06. So what we can do is plug that into our Pythagorean identity, and we can say cosine squared theta plus sine squared theta equals 1. But now I'm going to replace I changed my color there. Go back to blue. So sine is 0.6 squared, and we're solving for cosine. So 0.6 squared will be 0.6 times 0.6, which is 0.36. And we're just solving for cosine of theta. So we'll subtract 0.36 from both sides. And cosine squared of theta is 1 minus 0.36, which is 0.64. And now, just like in a normal equation, we can square root both sides. And that's going to eliminate my square on that cosine. So we have cosine theta is the square root of 0.64, which will just be plus or minus 0.8. And so remember, whenever we're taking the square root in an equation, we know we have a positive and negative solution. So that's why, again, we go back to this quadrant and we say, okay, is cosine positive? Is it negative? We already decided that cosine is going to be negative. So our answer here would be negative 0.8. That would be our answer for cosine. All right, so now we have sine that was given, we have cosine, so we can find tangent as well. So remember, a tangent we said was the same thing as sine of theta divided by cosine of theta. So tangent of theta is just sine, which is 0.6, over cosine, which is negative 0.8. So tangent of theta is 0.6 divided by negative 0.8 will be negative 0.75. All right, so I have cosine and it turned out to be negative, and tangent also turned out to be negative. So I'm just double checking that my answers are correct for quadrant 2. Go ahead and pause the video and try our second example to see if you can figure this out on your own. And after you've had a chance to try it, we'll go ahead and go over the answers together. All right, so hopefully you've had a chance to work through this example on your own, and now we will work through it together. So just like before, the first thing I like to look at is where my theta lives. So here I notice that theta is between 0 and pi over 2. So 0 and pi over 2 is between 0 and 90 degrees. So I know I'm in quadrant 1. And what I know about quadrant 1 is that cosine and sine, so remember this is cosine, this is sine, are both positive, which means if I divide those two, tangent is also positive. So everything is positive in quadrant 1. So what that means about sine is positive and tangent is positive. And I can also verify that my cosine is positive as well. So just like before, I'm going to plug this into my Pythagorean identity. I have cosine squared theta plus sine squared theta equals 1. Cosine squared theta is 0.25 squared. 0.25 squared is 0.0625. And now I'm going to subtract that from both sides of my equation. So I take 0.0625 and I'm subtracting it from both sides. So if I wanted to write that in real quick. Oops, I forgot a 0. So I'm subtracting that from, oh, forgot a 0 again, 65. So subtract that from both sides of my equation and I get sine squared is equal to 0.9375. So try not to round if it's a terminating decimal, just so that our answer can be as precise as possible. And now I will square root both sides of my equation, which eliminates this square on my sine function. And I have sine of theta is positive or negative. And I'll take the square root of my answer here, which is about, let me change this to approximately, because I do have to round in this case. And I'm going to round to just 3 decimals, so 0.968. And just like before, I investigated already the sign of my solution. So in this case, I know sine is going to be positive, we'll say about positive 0.968. So that is the answer for my first part of the problem. And now I can use my sine and cosine to find tangent. So I'll say tangent, remember, is sine of theta over cosine of theta. So tangent is going to be about 0.968 divided by 0.25. So tangent of theta, it will be, let's type it into my calculator, 968 divided by 0.25 is about 3.872. And so that will be the value of my tangent function. All right. So the last type of way that we can use our Pythagorean identity is when we're given tangent to find sine and cosine. So far we have looked at the first example, we were just verifying an identity, which just means showing that it's true for a given angle. And then in these next two examples, we were using sine or cosine to find, in this case, cosine, in this case, sine. And then once we had sine and cosine, we were able to find tangent.